We have discussed the Vcg mechanism to a certain detail in the previous modules, and apart from the technical details, we have also discussed where it is actually used, the internet auction. So therefore, it's the right time to discuss about some of the advantages and disadvantages of Vcg mechanism. Indeed, Vcg is one of the most popular mechanism in the context of mechanisms with transfers, but still it has certain shortcomings, and we are going to discuss that here. So of course, Vcg mechanism is nice because it is dominant strategy incentive compatible, which means that it has very little load on the bidders. If you are a small bidder, you do not know the nitty-gritty details of any mechanism, it will be much easier for you to know that the mechanism is truthful. So therefore, whatever your value is, you just reveal that value. So what can be even easier than that? It is also having the property that it has no deficit. So even from the point of view of an auctioneer, they are never going to give any subsidy to any player, and they are never going to run into deficit. So to run that mechanism, they can only earn money, but they might never pay any of these players. So they are also safe. So it never charges a losing agent. So if as a bidder, this is satisfying to know that if you lose the auction, then you are never charged any money. And it is also individually rational to participate. So if you are trying to auction for some goods, let's say the slots in an internet auction, then if you participate, then you are going to get weekly better off. In the worst case, you might not get your preferred slot, maybe not get any slot at all, but in that case you are not asked to pay anything, so you don't lose money. So these are certain good properties of Vcg mechanism and partly reason for its success. But still there are certain criticisms, and let's look at those cases one by one. So one thing is about the privacy and transparency. So of course it is very nice for the bidders who are having a low cognitive load, but it actually reveals the valuations of the types. So if you and your competitor are bidding for some object, you don't really want your values to be revealed to your competitors. So that is something that is not really happening in the context of VCG. All this private information actually becomes public after they have been announced, and because this is a truthful mechanism, everybody is expected to reveal their valuations in a truthful manner, and that makes a lot of privacy issues. The other point is about transparency. So maybe if you have a bunch of bidders where there is only one bidder who has a very high valuation and all the other values are really very low, so maybe it's just one major player. So then according to VCG, you are going to ask that bidder to pay the second highest bid, which will be very low. So from the point of view of an auctioneer, it is not really very useful. They are giving out that slot or the resource, but at the same time they are earning really very little. The auctioneer is not malicious. This mechanism works perfectly, but if there can be some instances where the auctioneer can be malicious, what they do is they actually introduce some fake bidders who are not real bidders. They bid something much higher than those the second highest bidder. They do not win because there is a larger bidder who is bidding even higher, but the amount that this highest bidder is paying is significantly larger. So there is a kind of a trust issue in here as well. You'll have to really trust the auctioneer that it is doing the thing that it is supposed to do in a truthful manner. Otherwise, this extraction of excess amount of money can happen. So this is one criticism about how this is implemented. The next criticism is about the collusion. So suppose there are multiple individuals who can potentially talk to each other and decide collectively that they are going to bid differently. Whether they are going to be better off or not, let us look at this example. So this example is for public goods. So there are only two possibilities. So either A will be built or B will be built, or this public projects will be undertaken. And suppose there are three players, player 1, 2 and 3, they have the valuations for this two public projects as shown in this table, not these red ones. We will come back to that later. Things that are shown in white is actually the real valuation for those players. Now you can compute the VCG payment, and you will see that this are the VCG payment. The third agent is a non-pivotal agent. Whether he is present or not, the outcome will always be A, so therefore he pays nothing. Now what player 1 and 2 can do collectively? If they bid instead of their true values, which is 200 and 100, they bid 250 and 150. So in that case, in fact, player 2, so these are the revised payments under that VCG mechanism. If 1 and 2 colludes and bids 250 and 150, in that case, player 2 also bids, also pays 0. And the payment of player 1 actually reduces from 150 to 100. This is happening because now even player 2 becomes a non-pivotal agent, so which is better for them, for player 2 and also for player 1. So they are still getting the same outcome that they were getting, but they are actually paying much less, and therefore this utility is going to increase for both these two players. So the third criticism about VCG is about its frugality. That is, VCG is guaranteed to be no deficit, so the auctioneer never loses money, but they can charge payment which is much larger than the cost, or maybe much larger than what you can expect to happen in that mechanism. So that is the frugality issue. So how can we actually understand this point? Let us look at an example of a network where all these ages are essentially the players, and they have a certain amount of cost which is their private information. The objective of the planner is to find the shortest path from the source to the destination, least cost path. And you can find out that this path here is essentially the least cost path. ABEF is the least cost path. So what happens? So if all these players are actually expected to report their costs, and we are running a VCG mechanism, we know that it is going to be truthful. Everybody will reveal its values truthfully. So there is no difference in this case. We are not distinguishing what is reported and what is true, because true will be revealed. But let us look at these two things. So the payment that we are going to make to this agent who is holding this age A to B, and the cost of this age A to C. So these are the two things that we are going to consider. Yeah, so the examples of this kind can actually happen in practice. Let's say an item delivery network for certain shipping companies. So since this is a cost setup, as we said, we are going to consider the negative of it and trying to maximize that. So what will happen for for the payment of P of A comma AB? So this is the age here. So this player is AB. So we'll have to find out the efficient allocation. So to compute the VCG payment, we'll have to first remove that player. So if you remove this age, then there is only one other possibility in which you can go. So you have to go via A to C, and then you have the possibilities either going through this path or this path, right? And you can find out that this is a shorter cost. So this path ACEF will be taken now, which has this cost of -2, -3, -1. So this is the valuation of that path. So this is the valuation to all the other players when agent I is not present. When agent I is present, for all the ages except this BE and EF is equal to 0, and for BE and EF it is 1 and 1. So that is going to be the valuation here. So in total, the payment of AB when it is the costs are as shown in red, is going to be -4 for this player AB, That's the VCG payment. And -4 means that this player will get paid because this is a cost situation, the cost scenario. Their valuations are actually negative, so minus of 3 is actually the valuation, and they are getting paid 4. So 4 minus 3, 1 is the net payoff for that player. Now what happens if so nothing happens in the shortest path. ABEF remains the same, but the value of this or the cost of this path AC has now increased from 2 to 8, let's say. So what happens to the payment to A comma B? Everything else remains the same, but this term, which was -2 earlier, now becomes -8, and that becomes that the player now gets 10 as a payment rather than 4, which was earlier. So you can actually, so 8 is no magic number. You can actually increase it to any large value. So the costlier this path AC becomes, you will have to make a large amount of payment to AB, which is the shortest path, even though their costs are much lower in this path. Because the other alternative, the externality of in this payment is really large. It is essentially imposing a lot of payment to the purchaser or to the mechanism designer, and that is one criticism. Even though nothing changes in the cost of the path that you are using, you might end up paying a very large amount of money to this agent's AB, and that is actually going to be true even for the other paths. If there are some critical edges where the alternative is very expensive, because the alternative is getting much expensive, you will also have to pay this agent, this particular edge, a lot more than their cost. So this is something that is not really very desirable. The fourth property of VCG is that its revenue monotonicity is getting violated. So what is revenue monotonicity? It means that the revenue is going to be weekly increasing in the number of players. When you have more players, you are expected that the competition will increase, and therefore the payment that they are going to make is actually going to be larger, right? So that is revenue monotonicity. But in this example, we will show that is violated in the context of VCG mechanism. So again, let's assume that there are two alternatives, two public projects, let's say football and museum, let's say. And there are initially only two players, 1 and 2, and their valuations as shown in this table. You can compute the VCG payment. It is going to be 0 for player 1 and 90 for player 2. Now let us assume that now the third player makes an entry and he has a valuation of 100 for the public project F and 0 for the other. Now you can recompute the VCG payment, and you can see that it is going to be 0 for all these players. And this is happening because none of these players are now critical. So none of these players are pivotal. So if you remove any of these players, the outcome does not change. So therefore everybody is going to pay the 0 payment. And that is really surprising. You introduced a new player who was actually having some valuation for one of these facilities, one of these outcomes. But because of his presence, and the players who were earlier paying some amount of money are now going to pay 0. So this is certainly one criticism, that from the point of view of an auctioneer, if the introduction of new players are actually reducing the total revenue, that is actually not something that someone will be happy with. The last point that I'm going to discuss here is that this mechanism, the VCG mechanism, is not perfectly budget balanced. Remember what was the budget balance condition, that your pi of theta, when you take the sum over all these players, is exactly equal to 0. And the reasoning or the justification for this budget balance is that as an auctioneer, so in the context where you are actually provisioning some public goods or distributing some objects, the auctioneer's goal should not be to earn a lot of money. Rather, it should just do the efficient allocation, which is not possible using a mechanism without money. And that's the reason the payments are collected. But if you have a lot of residual payment, or in some sense the surplus, then it is not really very desirable. But as we saw in the context of VCG, it's a no deficit mechanism, which is good. You don't really have some of the payments to be less than zero, but it is non-negative, but the sum of the payments can be really very large. And you cannot really say that we are going to redistribute this additional surplus to these players, because if you do that, then you are actually changing the payoffs of these players. And therefore this mechanism after redistribution is not going to be truthful. You can of course partition these players into two different classes. So let's say partition 1 and partition 2, and you run a VCG mechanism in partition 1. Whatever surplus is collected, you redistribute it to the players in partition 2, and you do the reverse. This is going to make the mechanism overall budget balanced, but the allocation that you are doing might not be efficient. In some cases, it may not be possible to do that, because there is only one decision that has to be taken. So let's say just the public project, you cannot really do this. But if you have object allocations, yes, maybe then you can do it in partitions. But because it is not efficient overall, you already lose the property of efficiency in VCG. So what finally happens if you want to run one single mechanism is that you take this surplus, you cannot give it back to this situations. So for this set of players, that amount of money is in some sense being destroyed. So this problem is known as the money burning problem. And this is one significant criticism of VCG. Even though it satisfies those properties, it is actually sometimes can lead to a lot of money burning. So there is a trade-off. So I am not going into the details, but if you want to understand the trade-off between efficiency and budget balance in general quasi-linear domains, I suggest this work of ours, which appeared in Games and Economic Behavior, that actually gives an idea about how the trade-off is and what is the necessary condition when you want to have budget balance. So it essentially says that asymptotically, when you have a lot of players, inefficiency actually goes away. Now, what I must remark at the end is these are just certain limitations of VCG mechanism. VCG, as I said, is still quite elegant. It satisfies a lot of properties and also being used in various contexts. The more people know about this mechanism, they can do certain improvisations of this mechanism and apply it in different contexts. So, but it is also important to know the limitations, to know where we can actually effectively use it.